Hello everybody, Namaste. Welcome back to my YouTube channel. I'm Anushka here again with yet another video. Today we will be focusing on computer networks subject in the course of engineering, and we'll be looking into three protocols and flow control and error control and detection. The first protocol that we'll be looking into is data link control protocol. Then we'll be also looking at framing, which is a part of HDLC protocol, that is high level data link protocol, and PPP, that is point to point protocol. We'll be looking into the depth of these topics as well, and we'll be looking into flow control and error control, which includes detection and correcting errors. And we're looking into how these two are different yet have certain similarities among themselves. Yeah, so this is all that we have to cover in this video. Let's begin. First of all, let's understand what is data link protocol. Data link protocol plays a critical role in secure and reliable data transmission across networks. Now, what do you understand by a protocol? Protocol are basically rules that a network needs to adhere. These rules are important to ensure that the data that has to be transmitted is transmitted from one node to another. Now, let's first understand what is a network, then coming to a protocol, and finally, data link protocol. A network could be a connection or interconnection of multiple devices. These devices have capability of communicating with each other by transferring data and receiving data. Okay, so this is what is a network. And what are these protocols? Now, suppose the data needs to be transmitted from node A to node B. These protocols ensure that the data from node A to node B is transferred securely. So this is a protocol. Now, what is a data link protocol? It plays a critical role to ensure that the data transmitted across the network is reliable. Let's explore the key concept of framing, flow control, error control, and examine real-world examples of the protocol in action. First of all, let's understand framing. Framing basically means frame is basically a boundary that is set for a message. Framing ensures that data is correctly interpreted by receiving device by defining the beginning and the end of each message. Now, frame will consist of the data, the actual information, that is payload. Will also consist of certain redundancy bit, which will ensure that these are basically extra bits that are added, which ensures that the data that is being transmitted is correct. And in the beginning, it might also have certain address where it needs to be transmitted. So a frame basically is a boundary which is fixed for a message, a payload. This message can be of 16 byte. Along with that, it will have redundancy bit, address, other sources as well. Examples in HDLC, that is high level data link protocol, and point to point protocol, that is triple P, are two widely using framing protocols. Techniques: frame can be achieved using start stop delimiters, flags, or byte stuffing methods. Let's understand flow control, regulating transmission rate. First of all, preventing overload. Flow control ensures that the receiver is not overwhelmed by data by managing the transmission rate. What do you understand by the transmission rate? The transmission rate basically tells us how much data is transmitted in what time. So this transmission rate need not be over the limit in order to make sure that the receiver is not overwhelmed. What do you mean by that? That means the receiver receives the actual amount of data that is being required and does not receive more or less data. Stop and wait. Now, this is a very important protocol. Stop and wait protocol is basically as the sender sends the protocol. Okay, not the protocol, I'm sorry. As the sender sends the message. When the message has been received by the receiver, an acknowledgement has been sent to the sender. How does this waits for acknowledgement before sending the next frame? Basically, as soon as you suppose if you have a message to be sent to your friend, suppose if you're sending a message like hi, you'll be waiting for your friend to reply back with a hi, that is an acknowledgement to be sent before you send in another information. So in this way, it helps in preventing overloading of the transmission of data. Suppose if the friend does not respond, you will not bother the friend with more messages. As you understand, maybe the friend is busy or he or she is not interested, so you look for other methods. So wait, stop and wait protocol works in a similar way. There is a sender and a receiver. A sender sends the message in the form of frames, and this receiver, as soon as the receiver node receives a message, an acknowledgement is sent back to the sender. Before this acknowledgement is sent, no other frame or no other message goes to the receiver. Then you have sliding window. The sender can transmit multiple frames before waiting for acknowledgement, improving efficiency. Coming to coming to error correction and detection. Now, error correction and detection are two main parts that can be covered. Now, error detection is simply a yes or no question if there is an error or not an error, whereas error correction is comparatively difficult because number one, you need to detect the error. Number two, you need to correct the error detected, and at times it is very difficult to identify the error. So, error identification comes under detection, which is a simple yes or no question if there is error or not, and correction includes first ensuring or confirming an error has occurred. Second is to correct that error at the exact specific location. Now, error can be of three types. First of all is single bit error. Now, what does that imply? Single bit error is basically nothing but when a message has to be sent from receiver to the sender. The error has occurred in a single bit. Suppose the message that had to be sent was 100. Instead of that, the receiver receives 101, and the end bit has an error of a single bit. That means only a single bit is manipulated or a correction has occurred only at the single bit position. You have multiple bit error, that means multiple bits have been corrupted, and burst error, that is nothing but a form of multiple bit error. It's just that the error has occurred in a sequential manner. Multiple bits have been corrupted, but in a sequential manner. Now, for error detection and correction, we have certain checks, certain rules that can be checked. First of all is party check. So adding party bits to frames allowing receiver to detect single bit errors. Then you have checksum error, which is you calculate on the data, which helps to identify whether the correct transmission has occurred or not. Checksum at the end, the receiver should receive after the checksum has been performed, it should be all zeros. Then you have ARQ, that is automatic repeat request protocol, retransmits frames that are detected as erroneous. Then you have reliability. Error control ensures that the data delivered accurately even in the presence of noise or interference. So what are noise? Noise are nothing but the corruption that occur. HDLC protocol. Now, what is HDLC protocol? It is high level data link protocol. What are these? These are the set of protocols that govern how data is transmitted between nodes. So it is the rules or regulation that the data needs to follow when it is transmitted from one node to another. First of all, you have framing. HDLC uses start and stop flag sequential to delimit the frame, that is to give the frame an actual size. Then you have addressing. We have an address field which identifies the source and destination of the frame, which makes sure that the data is not lost. The control field manages flow control and error recovery mechanism. So you can have a CRC bit, that is cyclic redundancy bit, which ensure we can check error. Then you have PPP, that is point to point protocol. Basically, it is computer communication protocol that allows data that has been transmitted between two routes without any disturbance of another route. So a flexible data link protocol. Framing, PPP uses flag bytes to delimit frame. So before we had a start and stop delimiter, but here we have flag bytes. That is byte stuffing method which is being used. Ensure unique flag pattern so that the message that has been encrypted basically is not identified by anybody else but only the receiver. Negotiation. PPP supports dynamic negotiation of options like authentication and compression, which ensure that the data has been transmitted and the data compression does not lose any data but decreases the size. Encapsulation can encapsulate various network layer protocols, making it a versatile choice. Data link protocols and actions. So Ethernet is 80% of them uses data link protocol, Wi-Fi uses 60%, Bluetooth 40, and others 20. Data link protocols are ubiquitous in modern communication systems, underpinning popular technologies like Ethernet, Wi-Fi, and Bluetooth. They ensure reliable and efficient and secure data transmission across diverse internet network environments. Moving on to the takeaways, framing. What is framing? This is basically the summary of what we have learned. Defining message boundaries is crucial for accurate interpretation of data. Even if a frame is displaced, the data that has to be transmitted may be decoded wrong with the receiver by the receiver. Flow control, regulating transmission rate. Basically, the amount of data that is transmitted in the particular time is transmission rate, which flow control helps in regulating that so that the receiver is not overwhelmed by the overload. Prevents receiver overload and ensures reliable delivery. Error control uses error detection correcting errors, which enhances the integrity of transmitted data. Data link protocols are the unsung heroes of modern networking, enabling seamless and reliable communication across a wide range of technologies. By understanding their core functions, we can better appreciate the critical role they play in our connected world. That's all for today's video. I hope you have good takeaways from this video. If you have any doubts, you can comment down below. I'm always ready to help. Thank you so much. Have a great day.